All right. So hello everyone. I'm Evan, and I am the author of Vue.js and the front build tool Vite. So, in case you don't know what Vite is, it's essentially a build tool that allows you to quickly build single-page applications, and it also supports a lot of other high-level frameworks, which you'll see in the talk very soon. But um, but since Vite is pretty widely adopted now, so I'll just make the assumption that many of you probably already know what it is and skip the part where I just like explain what really it is. Um, and a quick recap of how it's been going for Vite. Vite was created 4 years ago in 2020. And 4 years later now, it has crossed 15 million plus weekly NPM downloads, and has grown almost doubled in the past year alone. So the growth is pretty astonishing because Vite originally started as an experiment and a prototype for me. I was trying to create a faster dev server for Vue itself, but halfway through, I realized it actually can serve as a more generic development tool for other frameworks as well. So I decided to rework it and make it framework agnostic, and turns out a lot of other frameworks also liked it. So more and more frameworks started to adopt it, especially meta frameworks that involve server-side rendering. So this contributes to the much wider adoption of Vite today than I expected. And on top of Vite, we also spawned a unit testing tool called Vitest, which is essentially created from the frustration of wanting a unit test runner that understands Vite's own config format and just works with Vite with zero config. So in the latest state of JS survey, Vite and Vitess got a lot of support and love from the developers. So Vite got the number one most adopted, number one highest retention, number two highest interest, and also voted the most loved library overall. And on the other hand, Vitess was number three most adopted, number two highest retention, and number one highest interest. And on top of all this, we have a vast ecosystem. So there are pure front-end frameworks that defaults their tooling to Vite. Of course, there's Vue, there's Svelte, there's Solid, there's Preact. Um, React doesn't default to Vite, but a lot of the new React apps, single-page applications in particular, are being created with Vite instead of create React app. Um, Angular uses Vite as its dev server since version 16, and I do think they have interest in leveraging a bit more in the future. And on top of that, there are meta frameworks like Astro, SvelteKit, SolidStart, 10stack Start, Analog, Remix, and many others that's also built on Vite. So there is a clear sign of convergence between a very wide ecosystem in the web space where people start to think that it's probably a good idea to stop reinventing the same wheels and let's just build on something together as the common foundation. So yeah, so I think last year we were starting to see this sign, and probably it was a bit premature to say this, but I think this year, right now, V has become the shared infrastructure layer for the next generation of applications. And this is a lot of responsibility, a lot of pressure, in fact, because I would be the first one to say that Vite is not perfect, and having such trust placed on Vite really pushes me to think what we can do better to support what these frameworks need, and to make sure the next generation of web applications being built are actually built on something that's solid, on a good foundation, right? So let's take a deeper look into what can be improved inside Vite, and what specifically are the problems that we see that we believe need addressing. So going back to first principles, people love Vite because it makes web development feel simple again, especially when you just need a simple single-page application. Vite abstracts away most of the complicated setups for you, and most of things would just work out of the box. And it has a pretty simple plugin system to allow you to do customization. But the simplicity is really, most of the time when we create simplicity in the web space, we're really hiding complexity underneath. And Vite is really no exception in this case, because when I created Vite, I had to essentially hack together a bunch of different tools. Because when I was just doing the prototyping as a side project, I didn't really want to say write a bundler myself or write a TypeScript transformer myself, right? So I just looked around and see what's available. And turns out there are multiple great tools that already exist in the JavaScript ecosystem. But the sad thing is, a lot of them does one thing really well, but kind of lacks a few other features, right? That other tools have, and doesn't seem to have the intention to implement anytime soon. And this happens between multiple different tools, so they all have somewhat overlapping capabilities, but they also have some unique capabilities that each other doesn't have, right? Or properties or characteristics that we're looking for. So Vite ended up leveraging multiple different tools for different things. So we use ESBuild for as a bundler for pre-bundling your npm dependencies. We use it for the default TypeScript transform. We use its minification and tag lowering transforms during the build phase. And for rollup, we use it for production bundling, because rollup gives you better chunking control, and it's a bit more designed towards application bundling use cases than ESBuild is. Um, and its plugin system is a bit more flexible, which Vite's plugin system is also kind of based upon. So it's a superset of rollups. Um, and SWC provides transforms for React JSX plus React Hot uploads for React Fast Refresh. So when you build a React application with Vite, if you want hot module replacement, you need the fast refresh transform. By default, you can either pull in Babel, which is the default, but Babel is written in JavaScript, kind of slow. So if you want it to be faster, then you need SWC. But SWC is written in Rust, and its binary is pretty huge. So if you install SWC by default, it can be double the size of Vite and all its existing dependencies. So essentially triple your download size just by opting into SWC. So that's kind of a tricky thing to pick a default with, right? So we kind of give user different options. So first of all, you have to use ESBuild and Rollup, which are direct dependencies of Vite. Then you kind of have to use Babel in some cases, kind of have to use SWC in some cases. And it results in quite a few problems, right? So here is I'm going through a bunch of limitations we see in each tool. So ESBuild has limited chunk tree shaking control, and it has no React refresh transform. We wish we can use ESBuild for everything, but it just doesn't cover all those use cases, right? And then rollup is written in JavaScript, so its build speed uh, is is really great for something that is written in JavaScript. But when we compare it to something that's written in a native language like ESBuild or Rust-based bundlers, it's still orders of magnitude slower. And then there's the SWC, which has a heavy binary, and it has a bundler, but it's not really usable, unfortunately. So each of these toolchain or bundler, if there is one option that allows us to just like opt into one of them and solve all the problems, we'd be happily do that. However, unfortunately, there just isn't one. So we kind of have to rely on all of these things at the same time. So this creates some subtle problems. So first of all, because we use ESBuild for dependency pre-bundling, due to its speed, and we do it in production, or we do production bundling with rollup, right? Sometimes they have slight inconsistencies when handling, especially when handling some legacy dependencies that's written in CommonJS or transformed from CommonJS to fake ESM. Um, some weird legacy package formats that could be handled inconsistently between these two bundlers. And this can be annoying because sometimes you only find out about the inconsistency after you have shipped your code to production. So this is something we've always wanted to address, and it's kind of a pain point for some Vite users as well. And then there's the pipeline inefficiency. Um, Imagine if you're building a React application and you've opted into SWC with Vite. Your same source of piece code, the same TSX file that you've written, in fact gets transformed by by three different parsers four times over the build pipeline. So it first gets during development, it gets transformed by SWC, and then bundled by rollup, and then it is transformed and minified by ESBuild. So you see, with each of these tools, they're using different parsers, and they parse them into Java, parse the same source code um, into ASTs, transform them, and serialize it back to strings, then feed it into the next tool to be parsed again. Right. So there is a lot of duplication and wasted efficiency here, um, and this is something we've always wanted to eliminate. But however, due to the constraints of the tools that we have, we just cannot, and we kind of have to live with that in the today's Vite, right? And then there's another issue with Vite itself, is just the unbundled dev server that we chose to go with. So the original intention is that unbundled dev servers allow us to leverage native ESM, which makes a lot of things quite simple. Especially during development, you can just let the browser fetch the ES modules as needed, and we transform them on the fly on the server side. So this works pretty well up to a certain threshold, a certain level of scale. Usually, if your app has, say, around 1,000 modules, the browser can handle it without a sweat. However, there are really, really large projects. For example, we've seen projects with more than 10,000 modules, 10,000 source modules, excluding dependencies. And some of them also run on somehow dated enterprise development machines that may not be as powerful as the latest M3 or M4 machines, right? So in that case, the browser networking layer actually becomes a bottleneck, because even with HTTP2 enabled locally, it just like there's just so much overhead in processing all these requests at one time. It just blocks the development server page load by a really, really long time. So unfortunately, this bottleneck exists at the browser level, and there's not much that we can do other than uh, so we try our best to make the individual transform of each module faster. We can do pre-warming and all that. However, we cannot eliminate the network overhead, and that has actually become the biggest bottleneck in some extreme cases. So we do also think that having an extremely fast bundler that can bundle consistently between development and production can be really beneficial to those users, right? It's not all Vite users, but some users do have this problem. So we started thinking about the idea of unifying the bundler, i.e., build our own that actually covers all the things that we need. And that is why we started working on Rodan, which you've probably heard of. But as we are working on Rodan, we started also digging into the deeper layers of all these different tasks. For example, uh, to build a bundler, you need a parser. Which parser do we use? And once we have a parser, which transformer do we use, right? And then if we go a bit further, how about minification? How about hot module replacement? Right? All of these things require looking at the AST and manipulating it in some way and emitting code, right? And as I mentioned, we want to reduce the inefficiency as much as possible, which means ideally all these different tasks during the bundle phase should be handled by the same parser, the same set of transforms, right? The whole toolchain should be just aware of each other, which means it should be a unified toolchain, right? So and as we are thinking about this problem, we realize that the challenge that Vite is facing is kind of a reflection of the JavaScript ecosystem at large, right? Because there are these multiple uh, concerns or development tooling needs that we run into during the JavaScript development lifecycle. So we need to parse our code, bundle our code, transform our code, minify our code. So this is just all in the build part. Then there's linting, formatting, unit testing, uh, all these tools need to touch and process our source code. They need to understand the source code. But up to now, we're just relying on all these different tools that's coming from different sources, likely using different parsers. Just do their own thing without being aware of each other. And usually it's the end developer's job to pulling all the configuration files and making sure all these different tools work together nicely. And it's not an easy job. And that's why a lot of times people complain about front end being complicated. A lot of the complexity really results in having to make all these different things work together nicely and keep them updated and in sync, right? So to eliminate the inconsistency and inefficiency issues, really like a unified toolchain is needed. And in a way, that's kind of like easier said than done. Like we can claim, okay, like a unified toolchain is obviously something that will solve this problem, but it's hard. It's not easy to build, right? So here's what I think such a toolchain that could satisfy our needs would. There are a few characteristics that it needs to satisfy in order to fulfill this role. So first of all, it needs to be unified, right? Same AST, same module resolution logic for all the things we want to do, right? Your unit test runner and your bundler should just understand the same, understand your source code the same way. You shouldn't have to configure two sets of aliases, one for your test runner and one for your build tool, right? They should just all understand the same source of truth in terms of how to resolve files. They should have the same source of truth in terms of how to transform your files. You shouldn't have to do it once for every tool you're installing into your code, adding to your code base, right? And ideally, there's one AST to rule them all, so all your plugins can just work on the same consistent format, and there's no repeated parse, transform, and serialize cost. And then it needs to be high performance. I think it's pretty clear at this point that performance of written in native compared to native language tools is just much noticeably better than those written in JavaScript. I think in the early days, it makes sense for JavaScript developers to write tools for ourselves in the language that we're most familiar with. And I think in a way, also in the early days, because so many things are in change, in flux, and everyone is just trying out new ideas, writing things in JavaScript allows us to iterate really fast and cater to the ever-evolving, changing needs. But I think today, the needs has largely consolidated, and we have a much better idea of what we are dealing with nowadays. We have a much idea of what we need nowadays. So some of the targets are becoming more and more well-defined and slow-moving. And it is now a good time to start actually writing tools in a bit harder, slower to develop with languages, but also resulting significant performance benefits. For example, Go or Rust, right? Um, and then there's composability. There are attempts to provide runtimes or solutions that come with these all-in-one features or tools, but all these features and tools are coupled to a specific solution, which means you're essentially vendor locked into a specific runtime in order to use its linter or in order to use its test runner, right? And we want to we don't think that should be the case. We do believe that we want to have a toolchain that can be used individually, essentially, right? It should be available as crates, Rust crates, or available as npm packages that you can still pull into your own higher level tooling. If you're building some custom infrastructure, you should be able to just pull in the parser, just pull in the transformer, as source, and then compile it with your other dependencies, or use it in your own project, right? So it should not be one single black box that you can only call APIs from. And then finally, it should be runtime agnostic. As I said, I don't think people should be vendor locked into a specific runtime to be able to get such development experience. It is possible to have a consistent set of tools that just works with Node.js, works with For example, you can use it to develop target different platforms too. Like if your code intends to run in Cloudflare workers, you should be able to get the same DX. If your code runs only in a browser, you should be able to get the same DX, right? So I think it does not make a lot of sense for you to say you must be using runtime X in order to get a good DX for JavaScript. I think it should be just you need better DX for JavaScript, period. It should not be coupled to a specific runtime. Okay, so as I said, people might be thinking, isn't this too ambitious? It doesn't exist probably because it's too hard to do, right? So I think at this point, um, we decided, okay, it's time that someone do this, and why not us? So I have started a company called Vite Zero, and we've raised 4.6 million in seed funding to pursue this vision. And a lot of it comes down to the idea that we see that there is a rare convergence at Vite level, that a lot of frameworks are betting on Vite, trusting that it can serve as the future foundation to be built on top of. And we feel the responsibility, we feel the trust, and we feel there's a lot of momentum in making sure that that we can also leverage what Vite's position in order to sort of unify the layers underneath of it. I think that's a good opportunity to do that. And the reason we went with VC funding is because this is indeed a very ambitious goal, and I don't believe this is going to be feasible if we just relied on donations or sponsorships or just trying to uh, ask people to support us to do it, right? We need proper capital resources to get things started. We need to have a dedicated full-time team, hardworking engineers to solve these hard problems. Okay, so here's the big picture. There are a few projects that we are currently working on. The first one, the most foundational one, is at the bottom. It's called OXC. It is a language toolchain that includes parser, semantic analysis, transformer, minifier, resolver, linter, and a formatter. And it's a composable set of NPM packages and Rust crates that you can use each piece individually in your own toolchain as well. On top of OXC, we're building a bundler called Rowdown, which will serve as the future bundler inside Vite, which will make Vite's build more consistent and faster. And Vite will also continue to support Vitest, and in turn, Rowdown will be supporting Vitest. And eventually, Vite and Vitest together will support the higher level frameworks and tools that rely on them. So we've actually been working on this whole idea for a while now. So here's the progress so far, right? Just to show that it's not all vaporware. OXC has already completed the parser, which is 100% ECMAS 262 compliance. We also can, it can also parse TypeScript, JS6, and it includes built-in semantic analysis and control flow graph analysis APIs. The linter, OXLint already has 400 plus ESLint compatible rules, comes with IDE extensions. The resolver is based on Webpack's enhanced resolve, covers all the Node.js compatible CGS and ESLint path resolutions, and is fully customizable with like custom aliases, conditions, everything you can think of. And then there's the transformer, which transforms TypeScript, JSX, isolated declarations, which emits TypeScript definition files without going through TypeScript itself, React Fast Refresh. So the only thing that's still work in progress for the transformer is syntax lowering. And the minifier and the formatter are currently work in progress, and but we already have working prototypes for them. They just need to be a bit more complete. So we'll pick them up once we finish the transformer. The highlight of OXC obviously is the performance, right? The whole point of working on something new is really it needs to be significantly better. And performance is probably the most significant side of it. So everything we've built so far, we're happy to say that they are the fastest in each category that we know of. So OXC has the fastest parser, the fastest linter, the fastest resolver, and the fastest transformer. You can read into the benchmarks and comparisons in more details here, but notice that we don't even compare to Babel anymore because it's just kind of pointless at this point. Our main comparison targets are tools written also in native languages, namely Rust or maybe Go or Zig, right? So we compare with SWC, we compare with ESBuild. Um, the linter, unfortunately, there is not a direct equivalent, so we compare with ESLint, and usually for people who've tried OXLint with their existing ESLint code bases, they will notice 50 to 100 times speed up. Outside of just performance, there's also some interesting metrics that people often overlook. Um, so one is it actually uses less memory usage, and another one is it has significantly smaller binary size when compiled and shipped to your computer. Right. So surprisingly, when you use Babel transforms, it actually downloads 21 megabytes of JavaScript source code across 170 packages onto your machine. Whereas for OXC transform, it's one single binary for your specific platform, which is less than 2 megabytes. Um, so the Rodan. For Rodan's progress, we've already completed the basic bundling, OXC integration. So essentially, Rodan is now a pretty capable bundler that can handle mixed CJS and ESM model graphs, has source maps, can output all the different formats, has tree shaking, has 90% rollup plugin compatibility, can even do advanced chunk split control, which is something that rollup doesn't even have. And it has built-in support for Node.js resolution, package resolution, built-in TypeScript and JSX transforms. So right now, we are adding a bit of extra capabilities for Rodan, for example, first-class CSS, HTML, and SS support, to make it a more suitable application bundler that serves as the base layer of Vite. And we're also in parallel having a branch of Vite that uses Rodan instead of ESBuild and Rollup. And currently, we are already passing more than 90% of the tests. So we'll have a version of Vite that's running on Rodan, probably in beta status later this year. And for 1.0 beta, so we believe Rodan is pretty feature complete as a library bundler already, and you can already try it out. But we believe before 1.0 beta, we do want to give it a bit more polish and making sure there's more rollup and yes build behavior alignment, enabling more test cases, and fine tune the performance and improve the quality of the code. Some of the hacky places we want to clean that up before we enter beta status. And the performance Rodan obviously is the most important aspect of it as well. So in a benchmark case here, bundling close to 20,000 modules, Rodan finishes in 0.63 seconds. That's 20,000 modules. Actually, the current Vite, rollup-based Vite runs out of memory just trying to bundle this very case. And here, the Rodan Vite 1 is the work in progress Vite that's swapped to Rodan instead of rollup for the production builds. And we also have ESBuild, Farm, and RSBuild, which are other native bundlers that we're comparing against. So another case study is we swapped over. So there is a Rodan branch in the Vue core repository where we bundle Vue using Rodan and OXC transform. So we also enabled isolated declarations, which means we can also emit the TS definitions and bundle it without going through TypeScript itself. So the whole improvement is pretty impressive. So in Vue 3.2, we were using all JavaScript-based bundling build tools, and it took us almost 2 minutes to bundle all the formats because it's a Vue is actually a monorepo with 11 packages and 62 disk bundles. Right? So in 3.5, we moved a lot of the plugins, for example, the minifier and transformer, over to native-based ones, and we got things almost like 15 times faster. But uh, when we move over to Rodan and XC, we get another 8 times speed up, which makes it almost 100 times faster than Vue 3.2. Okay, so that's the progress so far. And what do we expect next, especially for Vite, right? So the most significant thing for Vite is its architecture is changing internally. So right now, this is what Vite looks like. We have the top half is the JavaScript side of Vite, which is Vite core, and the bottom side are the critical dependencies that we currently use. So in Vite Next, which is currently work in progress, we will have the non-JavaScript side, i.e. the native side, replaced by OXE and Rolldown, which is the vertically integrated toolchain that we're building, and making sure everything that needs to be handled in Vite is now handled consistently by the same toolchain and more efficiently. And in the future version of Vite, we're going to expand the native side a bit more to reduce, because there is one important aspect of it is there are some current responsibilities in the Vite JavaScript core is done as internal plugins in JavaScript, and they can actually be ported over to Rust side. Right now, leaving them in JavaScript allow us to get things working in with the maximum compatibility in today's applications. However, there's still a lot of overhead that we can eliminate by moving those directly over to Rust and reducing the overhead of calling between Rust core and JavaScript plugins back and forth, and also moving more logic to be executed on the native side. And the architecture also will allow us to handle the current some of the internal, for example, environment API and how server-side rendering applications are handled during development. Um, so by leveraging Rolldown's bundling capabilities to do those things, we can make things a lot more consistent and more efficient. So this is currently in prototype stage. And one capability this unlocks is the full bundle mode, which actually moves away from the unbundled dev server and back to using pre-bundled code for your development server. So this is quite necessary if you have really, really large applications, like more than 5,000 unbundled modules. And in our test cases, this does improve performance significantly. So again, this is server startup, including server startup and page load time for a pretty large application, and this is including HMR. So this is a work in progress prototype benchmark, but this is just here to sort of show you the progress of it and what to expect when it eventually lands. Okay, so that's it about what's going on in Viteland and what we're building. So what to expect, and thank you very much.
Hello there. Thank you very much for this talk. That was great. Really appreciate you and your time. I mean, I already know all the answers to the question, but I think Paul is over there, has some questions. So you want to go over that? You're muted. There's this microphone thing.
Of course, it wouldn't be a webinar without me doing this. Evan, we have a lot of questions, a lot of interest, a lot of good questions. I'll go through these quickly. So first question is a pretty detailed one about extending manifest.json.
Okay. From v.config, I guess this is a pretty specific one. So unfortunately, if I don't look at an issue with more context, like what's the use case, it's kind of hard to answer it here directly. Yeah.
Sure, no problem. This one's a lot more general. Next.js, you knew this was coming. You had to.
Yeah, unfortunately, I don't think this is going to happen anytime soon. So first of all, Next is Vercel is very heavily invested in their own toolchain, obviously. So TurboPack, they've been working on it for a very long time. And we have actually had team members looked into re-implementing Next on top of Vite. And we have a prototype that actually is able to run the app router, like 90% of its features with the app router playground. But in the end, I think the conclusion is the deviance of the internal architecture is so large. So in the long term, we just don't see a reasonable way to reconcile the differences down the road, right? So I think at this stage, unless Vercel decides to say, hey, let's go on Vite, then I don't think this is going to happen from the outside. But given how deeply vested they are in TurboPack, unfortunately, I don't think it's going to happen.
That's a
anytime
reasonable point, and probably a better question for them than for you. This is just an observation, but it leads to an opportunity for me to talk about the poll we did. A comment about easy to configure is the biggest value that they get from all of the work that you're doing. We did a poll asking, what do you value most from your build tools? Performance got 55%. And then points like this were the remainder. So it's interesting that, hey, guess what? You got it exactly right on what people in this talk, at least, were interested in.
Good news.
Do you get much comments from people that confirm that performance is the sweet spot?
I think, like as developers, like I think it would be weird for us to get to not welcome more performant tools, right? Because if you're doing the same task and things just run faster, you're saving your own time, and time is really the most valuable thing for us.
Indeed. I'll bring this one up. We only have 5 more minutes, but I'll comment that about syntax lowering. What is syntax lowering? Picto13 gave a great explanation of this, but if you would like to for the rest of the stream, what is syntax lowering?
Well, imagine you're writing a new syntax just landed in ES 2024 today, but it's not supported in the browsers yet. So the transformer may be able to downgrade it into something that most browsers today already understands. For example, downgrading it to ES 2015. So that's syntax lowering. Yeah.
And it's something that we're familiar with transpiling from long days past. Okay, Guillaume asks a pretty good question. What's the status of all this Vite Zero stuff?
Right. So we have so during the talk, I listed the things that's already completed, the things that are still work in progress. So the parts that we completed, for example, parser, linter, and transformer is also almost complete. They're already usable. Like you can check out the documentation. OXC's each part is available as either Rust crates or NPM packages. In fact, there are already companies that are using some of those pieces in their production code.
Maybe the Rust crate will be usable in Python for me. We'll see. Okay, we have a question about all the work that you're doing and kind of what you're thinking about for the commercial, non-commercial status.
Yep. So our end goal is to eventually build services that where the toolchain will serve as our funnel, obviously, right? But our toolchain, everything that we release as open source, will remain open source. We do not intend to monetize directly on the open source projects that we create. And in other words, we don't do rug pulls.
All right, great. Khaled asks a good question. You're doing all these optimizations, but you get into some tricky spots and things might not work at the end.
Yep. So this is why right now we are in fact doing a lot of alignment work, which means we have all the roll-up test cases. We run the roll down against the roll-up test cases. We also run roll down against ES build test cases. And essentially, we enable all the test cases and let them fail. And then we figure out what test cases are about correctness and what are about the specific behavior difference between the butlers. And we filter out all the test cases that are about correctness. For example, in this case, should we expect this to happen or not? Right. So essentially, we enable all the possible cases that we can find for the tools that we're trying to align with and make sure we pass those tests. And we do this for OXC as well. OXC actually, when we do the transformer, we're pulling all the Babel transform test cases. We actually find the Babel transform test cases to be not that complete. Like we had to add our own test cases to make sure like we are covering cases that's not even tested.
All right, here's one that will be a pretty quick one. Can Vite be used, and presumably the tool chain that you're talking about and in the future, can be used from Bun and Dino?
So Vite as a high-level tool, we rely on some Node.js APIs. I believe both are already supported in both Dino and Bun. So you should be able to just use Vite in Dino and Bun today without problems.
All right, great. All right, last one will be right on time. Gives me an opportunity to make another larger point. You had to know this one was coming. But I noticed that your round is with Excel, who is also behind Charlie Marsh and Astral, who are doing the stuff you're doing. But in my world of Python, they're also behind Laravel in PHP. So do you have any opinion on anything you'd like to say about business strategy?
So what I can say right now is we do intend to build services that use the technology that we're currently open sourcing as
Mhm.
funnels. We don't want to really get into the details of what exactly we're building at this stage because it's quite early. Uh, we probably will reveal them as we have more concrete things to show. But for now, our focus is really focused on open source adoption and making sure the tool chain gets widely adopted, serves this community well, ideally become the industry standard, and sets up for the real commercialization work that
Sure.
follows afterwards. Yeah.
On this point, I was thinking about you this morning, and you've been a kind of a voice of moderation and good taste for years in a world of JavaScript tooling that isn't always so friendly.
Thank
And
you.
you're actually like one of the elders now. I wonder if you ever think about, wow, I've been around for a long time. So I just like to say to everybody out there that, you deserve, people should have a little faith in what you're doing, and you've earned the right to say, hey, I'm thinking about this and things are going to be okay.
Thank you. Thank you. Yeah, it feels weird because this is the 10th year I've been working in open source now. Like Vue is 10 years old. I didn't really expect to be doing this as a career, but here we are.
All right, Jan, that's our questions. Back to you.
Yeah, I really just wanted to hook into what Paul just said. I mean, I'm mostly involved with the Angular community, but the tools you've been working on in the Vue ecosystem expanded way across that ecosystem. So I really just want to say thank you for everything you're doing and really appreciate you and your work and the
Thank you.
team you're leading. Thank you very much.